Hi everyone, this is the one topic that we don't cover from Physics 1, the AP exam. This sign here is the circular motion and this sign here is the rotational motion. The topic covered in the AP exam is the rotational motion, but first we need to understand the differences between these two motions. So the circular motion is what we see in advanced physics. It is the linear speed. And what's different, as you see in this here, is that when an object is moving, like this, the whole object is undergoing a rotational motion, whereas one tip of it displaces differently than another tip of it, which means that it has different velocities. So this is the difference between the circular motion, that one side or different parts of it is undergoing, versus a rotational motion that the whole object has. And this is different in many aspects. Here you see the displacement. The displacement of one side of an object, which is what V5 undergoes here, is delta x, whose unit is in meters, versus in an angular one, which is a rotational motion, the angular displacement is in theta, which means it's in radians. For velocity, this is the v we know from linear motion. It's in meters per second. And this is omega, which is angular velocity in radians per second. And this is the acceleration for this velocity, which is in meters per second squared, versus alpha, which is the angular acceleration in radians per second squared. In the linear motion, which is the circular one, there is a force that's measured in newtons, which is ma. But in the angular motion, there's a turning effect of a force, which is the torque measured in Newton meters. But what's different here is that the mass that we measure by kilograms in the circular motion turns into the moment of inertia in the rotational motion, which means that to find the torque, I need to use the moment of inertia times the angular acceleration, whereas in the circular motion, I use F equals ma. This is a very important aspect because when measuring torque, we need to also measure the work done by the force and then the kinetic energy, but we need to use the torque instead of the force. And in here, we use work is equal to F times the delta x, whereas in here, we need to use the torque times the theta, which is the angular displacement. And then lastly, for the kinetic energy, it's 1 over 2 mv squared for the circular motion, whereas it is 1 over 2 times the moment of inertia times omega squared, which is the angular velocity of the object. So if we would like to demonstrate rotational motion versus circular motion, when I'm turning like this about my own axis, my whole body is moving in rotational motion, whereas my hand and my other parts are moving in their own circular motions. They have different circular velocities, and my own body has a different angular velocity. If we want to derive equations from what we already did by comparing those two motions, we can find that in circular motion, which is right here, the acceleration equals the delta v over delta t, which is the rate of change of velocity. And then in the delta x, which is the displacement, it's v initial t times 1 over t at squared. But in here, which is the rotational motion, we can see that the alpha, which is the angular acceleration, equals delta omega, omega being the angular velocity of the object, over the change of time. And then here the angular displacement is equal to omega initial t times 1 over t alpha t squared, alpha being the angular acceleration. Here we can also have another equation derived from this one, which is v final squared equals v initial squared times 2 acceleration times the displacement. And then here, omega final equals omega initial squared plus 2 angular acceleration times delta theta.